Hey guys, this is Nick, and today we're looking at the problem. What is the average reaction rate for the time period between 15 microseconds and 30 microseconds using the data below for the reaction of N2 gas with O2 gas to form nitrous oxide gas? And we are looking at the average rate that these two chemicals will react at. In order to do this, we must find the change in concentrations between these two reactants for a certain time. And if we look at the formula for average reaction rate, it is delta, the concentration of reactants over the change in time. So if we look at the table, we can pick any time slots. And so for this one, I picked the time between 30 microseconds and 15 microseconds. And then you just plug in the concentrations that correspond with each one. So I did 3.6 micromolars minus 7.6 micromolars over 30 microseconds minus 15 microseconds, and you will get 0.266 micromolars over microseconds for your answer for the average reactant rate. And for the second problem, it states, what are the rate law and rate constant K for the reaction below, using the following data. So for this one, we are looking for the rate law, and that is equal to the rate constant K times the concentration of both reactants. And we can see that in the equation. So what we will do here is we will just plug in each reactant, which is NO and oxygen gas, and multiply that by the rate constant K to find the rate law. And then we'll be able to manipulate this equation mathematically to find out the rate constant K. In order to do this, we will plug in from any trial. For this one, I chose trial 1, and we'll plug in the initial rate and the concentration of each reactant that correspond and plug it in to the equation. So you'll get 0.0057 squared times 0.14, which are the concentrations of NO and O2. And you'll be able to algebraically find this. And here you'll get, after some simple math, you'll get 15.4 second squared over molar squared. And we were able to know that these are the units because this is a second order reaction. And we know this because as the concentration of NO quadruples, the concentration of O2 doubles, which lets us know that it's a second order reaction. Just for some highlights and overviews of what this video was about, is for part B, it's to learn about the equations that are involved in the rate law and how to manipulate that rate law equation mathematically in order to find K, where you'll plug in the initial rate and the concentrations of each reactant to finally find the K. And also for the first problem, look and find the average reaction rate by finding the change in concentrations of the reactants over the change in time.